Welcome back and welcome to lesson 12 in the Houdini Environment Beginner Series. We're going to continue where we left off, and this time we're actually going to create a new setup for our procedural house, creating a new area for the house. So if you remember what we've been doing in the last few lessons, we've taken these random primitives, which we've computed and measured based on our input shape, and we've been randomly sorting them and splitting them out and doing certain operations on certain parts of the object. And then here, over on this side, for the last two lessons actually, we assigned a random probability to each primitive. And then depending on what that random value is, so not a random probability, but we assigned a random number and used that to group these points based on that number. And now what we want to do is we want to take the objects here when they are grouped with the value that here we can see is rand greater than 0.66. So right here, if this rand value is greater than 0.66, we'll see it's being able to split into group panels, which will allow it to follow through here into this section of our network. So now let's look through here until we find maybe two panels actually. All right, here, 0.68 and 0.63. We want two that are above 0.66. Here we go. 0.82 and 0.92 are both above 0.66. So when we look down here on our panels, we can see that those have been assigned the group panels and are now valid for us to work with in this setup here. So what we wanted to do, if I go down here to the bottom, is create two random sides, or these two random sides, and we want to create our own custom model that can be extended into our scene. And the idea of this lesson actually is a challenge for you to apply some of the procedural modeling stuff you've either done independently on your own, or if you want to kind of take some of these ideas that we've learned so far on the rest of the house and apply those to this. So a couple ideas I came up with were a small fenced-in area with a wire fence, slanted staircase, ventilation system, maybe a covered patio. So if I template this house here by control clicking the purple flag and hit W for wireframe, we can see. And this house isn't super exciting, but for our purpose, it'll be fine. Here, we can see that these two highlighted orange walls now are where we're going to be operating here and where we're going to add our new modeling. So anything we want here, we can actually create. And I do actually encourage you to maybe do it separately, or maybe while I'm creating my own setup, you can create your setup to make something that you think would be cool to add to the environment. So what I'll probably do is this idea here of a small fenced-in area with some kind of maybe wire fence. So the way I'm going to set that up is first I want to operate on each of these primitives. So I'm going to use a for each loop, and then I'll probably create some kind of area here where it is extruded. Maybe I'll randomize the length of the extrusion, and then I'll collect the bottom area here of this primitive and maybe copy some points, some pillars to it, and then maybe I could add a little wire or a beam that goes across to connect each one of these fence pillars together. So to give a shot at making that, what I'm going to do here is I'm going to select these panels, and if you remember from last time, we sometimes have two panels. So in frame 34 we have two, and sometimes we have one. So we want to be able to handle the input if it comes in, whether it's in the X direction, the Z, the negative X or negative Z, and if there's one primitive or if there's two, and we want to be able to handle edge cases actually, so if there's 25 primitives later, we can handle those. So the way we're going to do that is with a for each primitive loop. We're now going to place that down, and here we can see we are allowed to access each primitive, and we can set up a network that runs over both of these primitives together. So the first thing I'm going to do is I'm going to extrude this, and I will maybe blast the bottom. So I could do that. So if I did that, I could extrude. Then I could push it here, maybe group normals by the base, delete everything except those bottom ones, snap those to Y, and then create geometry with that. I could also probably do a Boolean to where maybe I'll try a combination actually. That might be a cool way to do it. So I'll start with this extrusion. And now what I want to do is I want to group this bottom side. But before we do that, I'm going to do a fit function on this distance. So we'll say fit 0, 1. We'll do rand $f. And we'll fit that from 3 to 5. So now we have a random distance from 3 to 5 on every frame. We're going to delete everything that is not facing downwards, and we're going to do a delete node for that. And we're going to go by normal, enable, -1 on our z-axis. And we want our spread to be, right now it's deleting everything. So we want our spread to be like 10, maybe 15 just in case. And then we're going to do delete selected to delete non-selected. So now we just get this bottom panel, this primitive. Now what I want to do is I want to snap this primitive to the ground. The way I'm going to do that is with a wrangle. And I'm going to say v at p dot y equals 0. So I'm now manually going to set the position of each point, and I'm going to set their y to 0. And you can see that both in the scene view as well as the geometry spreadsheet. Awesome. Now what I want to do is I want to copy points. I want to create points actually along this surface here, this edge, and I want to copy a box to them. So the way I'm going to do that is with the resample first to create those additional points. And we can see that here. And I'm going to set this to a length a little bit bigger. But now you can see we've got these weird corners. So the way we fix that is on our resample node, we set resample by polygon edge to true. And then there we go. Now what we want to do is we want to delete the points that are nearby this incoming primitive, because when we copy the points, if I copy here and copy a box, we don't want fence pillars. I gotta make this box, excuse me, a little bit smaller. And you'll see here, our normals are being taken from this geometry here, which now they're currently facing downwards. And they're using those normals in the copy to points to place our box with that positive z direction. See this positive z facing downwards. So what we can do to fix this is we can take our box and we can orient that along the so the z-axis. We can make, instead of pointing upwards, we're going to make our box this direction. So I'm going to resize that by 0.1, 0.1, and 1. And now our box is in the z direction. So when we copy the points, if I hit space G to frame, it'll now copy those in the correct orientation that we're expecting. Great. But now we need to delete the points that are near this primitive. And the way we're going to do that is with a wrangle. Oops. U to go up. I'll give it a second to think. I'm going to connect this wrangle here. And then what I want to do is I want to go over each point here in this incoming stream, this 0 here. This is the 0th input for our wrangle. And I want to compare it to this geometry up here. So I want to look at this stuff, this geometry, and I want to say, for each of these points, find the distance to this geometry, save it, and then if it's less than maybe 0.2, then delete it. Delete that point. So the way I'm going to do that is connecting that to the wrangle, the second input on the wrangle, and I'm going to get the distance. So I want to do float dist equals, the way we do this is a few ways to do it, but what I'm going to do is xyz dist, which gives us the distance from a point to the nearest surface on a different geometry. The surface I want to do, because it's coming in input 1, which is right here and not the leftmost, I'm going to say 1, and the position I want to start the search from is P. And now nothing happens, and we don't see any attributes here because we haven't saved those yet. So if I did want to save that, I could do float, not float actually, excuse me, f add distance equals dist. And now we have this, we have our distance. Now let's say, all right, we want to delete points that are less than maybe 0.1. So I'll say if dist is less than 0.1, then I want to remove point. What point do I want to remove? I want to remove from the 0th input, so this input stream right here, and I want to remove point num, which is the current point we're actually reading over right now. And now there we go. This wrangle now deletes that point, and it removes it, so now there's no longer any points that are within 0.1 units of this geometry here. And now we've got our points correctly copied. And if I did a match size, I could either put this match size here. Whoops, I don't want this connected. I want to match right in this size, nothing on the X, nothing on the Y, but I want to match our Z, or excuse me, our Y, I want to match min and nothing on the Z. And I just want to place that here. So now it snaps the base of this pillar up towards the floor of our world. And the way we could also do this is actually we could position this box before we instance it. So since we know it's on point, it's 1 unit long on Z, I'm going to space G. If I slide this 0.5 units here, so if I put this at 0.5, now when we copy to points, it's going to copy based off this center. So now this is automatically, whoops, aligned. And it looks like actually it is copying based off the center, but because our geometry now has normals facing downwards, that it will copy that with the fence post facing downwards. So we're going to reverse the normals here, and that will fix the issue. And now I'm going to delete this. I'll actually disconnect this and move this down for when we connect it later. And I want to see what we have so far. There we go. So that's a good start. But now what I want to do, I'm going to add some thickness to this wall here. And the way I'm actually going to do that is I am going to steal our wrangle from earlier, which we use to round the normals here. And I could copy this node. I'm going to shake to disconnect it. And if you remember from the last lesson, what this did was it took our geometry and it rounded the point normals to the nearest integer, which essentially snapped them to move either in this full Z, full X, or full -Z or -X. And now if I do a poly extrude along a value here, it won't use that yet, but what I can do is set extrusion mode to point normal and from pre-compute to existing. And there we go. Now I'm going to set this to 0.2 or maybe 0.1, and I'll output it back, and then I'll merge that as well. So I'm going to disconnect this wire because I only want the geometry we're actually going to keep for the rest of our setup. So now with these little artifacts here, I could add a normal node, which will fix. I just shook to disconnect it because I held down shift and it automatically placed it up there. So there we go. Now what we want to do is we want to add a ridge that goes across these and maybe connects the pillars to each other and then to the house. So the way I'm going to choose to do that is actually I'm going to go here, and I want to try to figure out a way to use a Boolean to show you guys how to do that. So let's maybe get a new plane, and I'll actually show you. Let's do this. So I'm going to create a bound, and I want to get a new grid that is the size of this entire setup, so including this wall here. And the way I'm going to do that is with a bound, which will give me a box, and then I'm going to delete everything but the top. So delete, disable the number, go by normal, and then I'm going to set the spread angle to 5, which technically it could be 0, but I'm going to put it just in case. And now it's going to say delete the top face, but I want to do delete non-selected, and now we have that. Now what I want to do is I want to snap this down to the bottom. So actually I could snap it down to the bottom, or I could have just used the bottom side of this box, but I will actually snap it to the bottom to show you how to do that. So I can use a match size again. I'm going to rearrange this object here. Snap the none on X, none on Z, and min on Y. And there we go. Now we have the bottom of this grid, which is the size of this entire thing. Now what I want to do is I want to offset this by a little amount, maybe 0.6. And then I want to sweep this, but I also want to remove the inside points here. And actually, maybe I don't, because it might be cool to have these blending into the wall. So let's see what it looks like now. So if I do a sweep here on this object, with a squared tube, and I'll decrease these and make this maybe 0.5, not 0.5, 0.05, and then merge these together, we'll see what happens. All right, that looks good, but I want them to be intersecting. So what I could actually do is transform this bound to be a little bit smaller, and I could scale it either after I delete this, or what I could do is I could actually scale the bounds by a certain amount to get it evenly split. And by that, I mean this bound, I can add an inner padding to shrink it, and I'll shrink it by a constant amount. So if I select down here and then select this bound, by increasing or actually decreasing this with a negative inner padding, you can see it slides that plane inside. So we'll do negative 0.01, which is not enough. 0.05 is our width. So let's do negative 0.025. Make it even, but we don't want it exactly even, so let's do negative 0.04. There we go. Now it's inside, and we'll do the same thing on the Z, negative 0.04, and then we'll also do the same thing on the upper padding. And I want this to be a negative number. And there we go. And actually now for these, I want this edge to be inside this side here. So maybe we'll make that a little bit less. Maybe negative 0.15, maybe negative 0.15. And then I'll put these on all four. And there we go. Now what I could do is I could make our sweep just a little bit bigger. 3.2. And there we go. And what I want to do is I want to have these all intersecting, because when I remesh this later, I want them to all combine. I can actually show you now really quick. So if I do VDB, whoops, not that one. So VDB from polygons, combine them all here. This will create an SDF, which is the signed distance field. It's a type of VDBs. But what I want to do is 0.01 maybe. We'll make this object here. And then if I do a VDB smooth SDF, I can smooth out this area, and then I can do a VDB to, actually a VDB convert will let me convert back from an SDF, which you can see here is not actual geometry. I can convert from volume to polygons. And now you see I have these objects, and they're all nicely actually blended together. So these little smooth transitions between each of these objects, which we did not have when we were actually modeling. And I'm doing that because I want this all to be a concrete fence. So maybe it's stone, maybe it's concrete, and maybe there's patches in between. So it shows that they are one uniform piece. And then this will actually look really cool when we do a ambient occlusion mask to get some darker edges, maybe some dirt buildup inside these, or some dirt anywhere else. So since we do that actually later, we're going to connect this to here, and we're actually going to maybe split up. Whoops. So let's see what happened. All right, so I've selected this N1. I'm going to reset the cached pass to see if that was the issue. Which it looks like it's not. So we're going to figure out what happened. Maybe I'm just on a different frame that doesn't have the object. All right, that looks like it must have been what happened. So some of these frames here do have the random chance set for panels, and some of them don't. So you might get panels on some, and you might get no panels, and you might get 2 panels actually for the fencing. So here we have 2. And now what I'm going to do is I'm going to bring this down, connect it to stone. And now we are going to go back to the rest of our building and see what this looks like. So there we go. Not the most complex setup, but you're welcome to expand it as you see fit. I just wanted to show you how that would fit into the rest of the setup, and then we'll actually continue in the next lesson to prep the VDBs, the surfacing, and then all those extra attributes. And then we'll see how this new setup we just added will kind of create some cool effects for the ambient occlusion, for example, or some other setups. And it looks like here I got a little bit messed up because I was dragging my network all the way around. So let me fix that. Delete this one. And this was just for me blending attributes with our objects, which we'll learn about in the next lesson. So that's me getting ahead of myself. So awesome. That was this little modeling exercise. I do encourage you to continue to add your own stuff. And maybe once we finish the series, you can go through and create your own buildings or create your own setups that could have really anything. So you could even extend this to be a whole city, multiple stories. And I encourage you really to try and maybe even break the setup to see kind of how it works and how to debug it as it comes along. So awesome. Thank you so much, and I will see you in the next video.